Well, we have a question here that says we have a sigma notation. The sigma notation stands for the sum. Okay, it says the sum of -3 to the power of p starting from 4 to 21. Okay, I'm gonna write the sigma notation over here. That's 3.1. That says the sum of -3 to the power of p, and then p starts from 4 to 21. So question 3.1.1 want us, the question says write down the value of the first three terms. So the first three terms, they are like T1, T2, and T3. So we're looking for T1, the value of T1, the value of T2, and the value of T3. Now, looking at the question, we know that T1 then, because the sum starts from 4 to 21, this implies that T1 is when p equal to 4, and T2 is when p equal to 5, and T3 is when p equal to 6. Okay, so now, basically, we're looking at T1 will be then -3 to the power of 4, which implies that T1 will be equal to 81. Okay, T2 will then be -3 to the power of 5, which is equal to T2, which is equal to -243, and then T3 will then be -3 to the power of 6. Which is equal to, which implies that T2 will be equal to 729. So these are the solutions. For question 3.1.2, then the question says write down the value of the constant ratio. All right, the constant ratio will just be the same as the value over here. Okay, because why am I saying that? Let me move this a little bit this way. I want to say 3.2 here. 3.1.2, I'm looking for the constant ratio. We do know that the sum, the sigma notation stands for the sum, and then the parts, this part here inside the sigma notation, this part is the term, is the Tn. Okay, and then Tn in for exponential or geometric sequence is given by a r to the n-1. Now I can notice that comparing this Tn, which is equal to -3 to the power of p, I understand that r here is just -3. Okay. So it's the part that has the exponents, and p is like n-1, and then a is just 1. This is a 1 in front of an invisible 1 in front of the r. So it's 1 times -3 to the power of p. A is equal to 1, r is -3, and p is n-1. So therefore, r is just -3. So that's the value of r. All right, let's see, the following question says what? Well, question 3.1.3 says here, will the sum of -3 to the power of p starting from 4 to infinite converge? Explain your answer. All right, let's see. I'm going to write here 3.1.1.3. All right. We're asking if the sum of -3 to the power of p starting from 4 to infinite converge. Okay. There's a condition for a sequence or a series to converge. The series converge if the constant ratio lies in between -1 and 1. Okay, that's the condition. What's the condition? Condition. So now, when we look at here, -3 does not lie in between. -3 it does not lie in this interval of -1 to r less than 2. Therefore, we say it does not lie there. So therefore, we say the series does not converge. Does not converge. Okay. All right. Now let's move. See the other question. Question 3.1.4. The question says calculate the value of this sum -3 px. Give your answer in terms of x. All right. I'm gonna move this over here, and then I'll write see a question 3.1.4. This is what is given: -3 to the power of p, and x times x, and then p starts from 4 to 18 to 21. 21. Now, the question says we are going to work out the value of x. Okay. So now let's do it. -3 to the power of p times x. We know this is a geometric sequence, right? A geometric sequence is given by a certain formula. I'm going to write the formula here. The formula is given by the geometric sequence is given by Sn equal to a open bracket 1 minus r to the power of n close brackets over 1 minus r. Or similarly, Sn will be a open brackets 1 r to the n minus 1 all over r minus 1. It's going to be related to the same answer. So the sum then it's going to be now we need to look at how many terms are here from 4 to 21. Okay, how do you calculate the number of the terms from 4 to 21? The way we calculate the number of the term is given by, okay, I'm going to say here number of the terms, or n actually will be, all right, here n will be equal to the upper limit, okay, upper limit minus lower limit all plus 1. Plus 1 because even the lower limit is inclusive, okay? So it's always like that. So n here will be equal to, n will be 21 minus 4 plus 1, which makes that n equal to 18. So basically, we're calculating S18, okay? Because there are 18 terms here. The first term, A, was calculated. It was when, if P equal to A is the first term, okay? A will then be -3 to the power of 4, -3 to the power of 4 times x, which is 81x. So now we're going to have positive 81x, open brackets 1 minus, I prefer to use square brackets over here because I'm going to use another bracket there. So square brackets here, I'm going to say the 1 minus r, which is given by -3 to the power of the power of 18 close bracket all over 1 minus -3 to the power of minus -3. Now, working this out, whatever it is, because basically in the calculator, we're going to work out this fraction and whatever we get with times by each 1x. And this will be equal to -7, 8, 4, 5, 2, 6, 4, 8, 8 to x. So thank you.